have already gone through all the questions today, and I hope that this time you must have found them on the easier side comparing to what you had on last Sunday, right? So let's go through some of these questions. In fact, all of them, and I will try to explain you. Maybe there exists a better method. Please let me know. So let's start. Very first problem says, what is the difference between the sum of first 2021 even counting numbers and the sum of first 2021 odd counting numbers? Honestly, tell me, how many of you misinterpreted the question, misread the question, and you thought that there are 2021 natural numbers, out of which we have to count even and odd separately and then subtract them? You know, 50% of the students told me that they did this mistake. What have you learned? Always read the question carefully, because this question says that what is the sum of first 2021 even counting numbers. So you have to take first 2021 even counting numbers, which are what? 2, 4, 6, 8, and so on to obviously 4042. I multiply 2021 by 2. Similarly, if I take odd counting numbers, it will be 1, 3, 5, 7, and since I will take 2021 numbers, so it should be 1 less than 4042, which is 4041. Now, my task is to add all of them separately, these numbers and these numbers, and then subtract. Well, I can do that. I know arithmetic progression, but then obviously there could be a better approach. What? Because, you know, we have to add all the numbers in this group. We have to add all the numbers in this group, and then we have to subtract. But what if I do this separately? Even minus odd, even minus odd, even minus odd, even minus odd. If you subtract these numbers, what will you get? You will get 1 every time. And now if you add, because eventually you're going to add, how many ones you have got, it should be exactly equal to the number of numbers. So the answer is 2021. Ta-da! It was very easy, right? I know. But the only problem could be, you know, if you have not got the correct answer, the reason could be that you have not read the question carefully. So be careful next time. In case you have got it correctly, very nice. Let's move to second question now. Well, the average of 20 numbers is 30, average of 30 other numbers is 20. What is the sum of all 50 numbers? I know. Almost everyone, I would say 100% of you would have got the correct answer, because, you know, what is the formula? What is the formula of mean or average? It is obviously sum of all the numbers, sum of numbers divided by number of numbers. So by this formula, if you see, mean of 20 numbers is 30. So mean is 30. Let's say sum is S1. I'll call it S1. And the number of numbers, obviously 20. So that's how you get 600, right? The average of 30 other numbers is 20. Look, 30 other numbers is 20. So this time mean is 20. And let's call the sum of, let's say the sum of numbers is S2. So this time it is S2 upon 30. But when you will cross multiply, you will get the same thing, 600. So what is the sum of all 50 numbers? Here we have these 20 numbers. Here we have 30 other numbers. So what is the total sum? Obviously, it is going to be 600 plus 600, which is 1200. And that's your answer. So this question was very easy. Enough. 4 marks were actually gifted to you. I don't think there could be a reason that you will not get your answer correct for question number 2, right? Let's move to question number 3. Whoa, sirs. When we look at powers, we do not feel very good. But I think this question is also comparatively easy. What you are going to see down there after 6th, 7th problem, I think this question is relatively easy. Because if you know about surds, if you know about this fact that nth root of x is nothing but x power 1 by n, you can easily get your answer. Right? Let's see what is this question. So this is cube root of x into cube root of x into cube root of x root x. Now this time I will write root x. Root x means it is x power half, that we know. Now I know if I have same base and these values are getting multiplied, so clearly I will get, what I'll get, x into x power half is what? X power 1 plus half, which is x into x power half is x to the power 3 by 2, isn't it? So this will become x to the power 3 by 2. Now look at this cube root. This cube root thing can be written as 1 by 3, right? Whole power 1 by 3. So 3 and 3 gets cancelled. 3 and 3 gets cancelled. And look, x is waiting for this. What is this? This is again x into x power half. So once again, when you will multiply x into x power half, you will get what? X power 3 by 2. And again, it's cube root. So 3 and 3 will again get cancelled. And you see x into x power half, it is again x power 3 by 2 cube root. So no matter how many cube roots you apply, right? If you, we have 3 cube roots here. Let's say we have 10 or 100 or 1000 or unlimited cube roots here, and infinite cube roots here. The answer will remain same, right? Because every time this x will be multiplied to x power half, and then we will raise 1 by 3, 3 and 3 will get cancelled. So eventually we are going to get x to the power half, right? So the question was, if x is 625, what is your answer? So we know 625 power half, that is root over 625, answer is 25, correct? So answer to this problem is 25. Let's move. And coming to 4th question. Whoa. What is the level of this question? You must have seen such questions in 6th or 7th grade. So anyways, let's see how to solve this question. Sum of 3 numbers is 20. A basic algebra problem where sum of 3 numbers is 20. Let's assume the 3 numbers to be A, B, and C. The first is 4 times the sum of the other 2. So let's say A is the first number. So A is 4 times B plus C. Look, sum of the other 2, right? So let's call this equation 1. If A is B plus 4 times B plus C, so I can say B plus C is A by 4. So why I'm trying to write B plus C as A by 4? Because now in first equation I can substitute the value of B plus C, right? So by equation 1, I will get what? A plus A by 4 is equal to 20. And now you can solve this for A. You will get 5A by 4 equals to 20. And then you will get A is equal to 16. A equals to 16, right? Right. So A equals 16 is done just by, looking at 2 informations, that sum of the numbers is 20 and first is 4 times the sum of the other 2. But then the second time is 7 times the other. Now look, if I have the value of A, I have the value of B plus C also. So what is the value of B plus C? B plus C is, if you subtract 20, A from 20, you will get 20 minus 16, which is 4. Now B plus C is 4. And look, second, let's say B second, is 7 times a third. So also we have this information that b is equal to 7c. And if I'll substitute this in equation number 2, b equals 7c, what you will get? 8c equals to 4. And this gives you the value of c, which is half, isn't it? Answer is half. So answer is half for C. And now what's left? What's left, guys? Now we have to find the value of B. What about B? If B plus C is 4, if you substitute C in equation number 2, this equation, you will get the value of B. So what is B? Tell me. What is B? B is 4 minus half. The value of B is 3.5 or 7 by 2. So now we need the product of these three numbers. And I don't think we need any sort of calculator. This type of calculation, it is very easy, right? 4 to 16, answer is 28. So answer to fourth column is 28. I believe everyone must have adhered to same sort of solution. And this question was actually very easy. So everybody must have got the correct answer. Let's move to fifth problem now. Huh? Oh. So here we have a problem in geometry. Let's see what is the question. We have these two triangles, ABC and ABE, share the common side AB. Yes, we do have two right angle triangles. You can see this is a right angle. This is also the right angle. That means AE is parallel to BC, isn't it? Then we have side lengths as shown in the diagram as well. AB is 4, BC is 6, A is 8. And AC and BE, they're intersecting at D. This is their point of intersection. Now, what is the difference between the areas of triangle ADE and BDC? This triangle, ADE, and this triangle, BDC. Now, there are a lot of approaches to solve this problem. When I look at this problem, I get many ideas in my mind. Out of which, the first idea is, because these two lines are parallel, so we are currently looking at two similar triangles, isn't it? See, this angle is same as this angle, right? Since these two lines are parallel, this angle is going to be equal to this angle. So we are looking at these two triangles which are similar. And what is the rule? What is the properties you have learned in symmetries? Similar triangles. What have you learned? Let's say area of this triangle is delta 1. Area of this triangle is delta 2. What do we know by similarity? I think everybody must have gone through this chapter in 9th or 10th standard, and they know by the fact that the ratio of the areas of two similar triangles is equal to the square of the ratio of their sides, their heights, or whatever. So I have an urge to use this property. Why? Because I have these two sides. I have 8 and 6. So I can directly say it is going to be 64 upon 36. Did you get it? So I can directly say delta 1 should be proportionality constant. Let's use the proportionality constant K. Delta 1 should be 64K and delta 2 must be 36K. Wow. 64K, 36K. कहीं से इस K की value मिल जाती, would have been happier, right? Because then what I want to find? I want to find the difference of the areas. I want to find delta 1 minus delta 2. Obviously, delta 1 minus delta 2 is going to be 64K minus 36K, which is 28K. So all I need to know is about this K. How to find the value of K? Let's see. What other information we can extract from the diagram? Let's call area of this triangle ADB delta. All right. I'm calling this delta. Now, I do not have delta. I do not have delta 1. I do not have delta 2. But if you look at this diagram, I have delta 1 plus delta. Don't I? Tell me. do we have delta 1 plus delta? Look at this. Delta 1 plus delta. Area of triangle ADE plus area of triangle ADB. It is area of triangle EAB, which is a right angle triangle. What the area is going to be? Half base into height. Half 4 into 8. And this is going to be equal to 16. Similarly, if I ask you what is the area of the sum of the areas, delta 2 plus delta 2 and delta, if you add these two areas, you're going to get the whole area of triangle ABC. ABC is a right angle triangle. Obviously, once again, the area of this triangle is going to be half base into height. So 1 by 2 into 4 into 6, and this is going to be 12. So why I'm doing this? Why? What is the use of this? Why I'm trying to find delta 1 plus delta and delta 2 by delta? Because now if you subtract delta 1 minus delta 2 comes out to be 4. You have got your answer. What was the purpose of telling you about this property? Look, the question says that we have to find the difference of the areas of these two triangles, and I have got our answer. Answer is 4. But what if the question says find all the areas individually? Let's assume. In that case, you can see, you can equate 28k. I'm just appending the question. 28k equals to 4 and k equals to 1 by 7. And now by just substituting the value of k here, you can find the values of all the areas individually. Right? So not just their difference is fixed. Finding their difference was comparatively easier. It was actually very easy. But if it would have been asked to find the areas individually, we can do it also, right? And once you have delta 1 and delta 2, you can find delta as well, right? You can find the area of triangle ADB also. So this question I'll rate as the difficulty level of this question was medium, right? It was not very easy, but again, not very difficult as well, right? Let's move to question number 6. Question number 6. Once again, a geometry problem. Let's see what the problem says. We have a square ABCD, fine. And in this square, a semicircle with diameter AB. All right, this is a semicircle with diameter AB constructed inside the square, and the tangent to the semicircle from C intersects AD at E. That we can see, it is E. What is the length of DE? So we have to find this length. Now, whenever you see circles, obviously there are few theorems which you must have gone through in 10th standard. The point of contact here, I'm going to name it ABCD. Okay, in natural progression, I will get F, right? So let's assume this point to be F. Now, just by looking at this diagram and try to recall those theories which you have learned in 10th standard. One of the theories says that tangents drawn from an external point will be of equal length. If you're drawing tangents to a circle from an external point, the two tangents will be of equal length. Tell me, where do you see two tangents drawn from an external point? If you take point C, look, CF and CB. These are two tangents drawn to the same circle, right? So CB should be equal to CF. Let's assume the side length to be A. If this is A, let's say, then this is also A. All right. One more pair of tangents can be seen, and these two tangents are drawn from the point E, right? From E, we have X, EF is X, and EA is also X. If I assume this to be X. So what is DE? In this case, DE will be A minus X, right? What is DC? Look, this is a square, right? So it is going to be, the side length is going to be constant. It should be A. Now look at the triangle, the right angle triangle, CDE. Angle D is 90 degrees. So we can apply Pythagoras. Obviously, we know that CE square is going to be equal to what? DE square plus BC square. Pythagoras, you all know about Pythagoras. And do we have these side lengths? Yes, in terms of A and X. For example, what is going to be CE? You look at CE in this diagram, you can see it is CFA and EF, which is X. So the entire length is going to be A plus X. So this is A plus X whole squared, right? A plus X whole squared. And A plus X whole squared equals to what? DE square. DE I've written as A minus X whole square. And DC which is A. Now, how long will it take to find a relation between A and X? You see, if you shift this term to left-hand side without opening these squares, you can recall that algebraic identity which says A plus B whole square minus A minus B whole square is 4A. So this is 4AX equals to A square, which tells you that X is simply A by 4. And if X is A by 4, what do we need? We need DE, which is A minus X. Look, DE is A minus X, not X, okay? So what is DE? DE must be equal to A minus X, which is A minus A by 4, which is 3A by 4. And now you can plug in the value of A, which is, see, it is 4, right? This one is 4. So substitute 4 in place of A and see what do you get. Wait. So DE is equal to A minus X equals to A minus A by 4, which is 3A by 4. And since A is 4, A itself is 4. So answer is what? Answer is 3. How difficult was this problem? Okay. It's again a medium level problem, not very easy, but not very difficult too, right? We just used a very basic theorem from tangents of circles, that if two tangents are drawn from an external point, you cannot maybe make more than two tangents, right? You can exactly make two tangents from an external point to a circle, and these two tangents will be of equal length. All right. So I hope you must have understood. Let's move to question number 7. In question number 7, it says non-congruent triangles with perimeter 9 with integer side lengths. Look, in a triangle, I have the perimeter, and I have one more information that all side lengths are integers. All side lengths are integers. You know the notation we use. This side is A, this side is B, and this side is C. What is given? That all three sides are integers. And you have to mind this. Otherwise, what would have happened? If they would not have said that sides are integers, trust me, the answer is going to be infinite. I think you can also comprehend why answer is infinite, because we have too many choices. But since we have sides in terms of integers only, it cannot be 2.5, it can be 2, it can be 3, it can be 4. Then we should have finite choices, because the perimeter is given, right? We have A plus B plus C, which is equal to 9. Now what? How should we proceed? What do we know about a triangle? When a triangle can be constructed? For triangle construction, there is a condition which says that sum of two sides. You must have heard it in those revision classes I took a few weeks back about triangular inequality, right? So sum of two sides should always be greater than the third side. Without loss of generality, let's assume that A is the greatest side. A is the greatest side. So it is enough. Now it is enough to say that B plus C should be greater than A. And how can this help? B plus C greater than A. Fine. Sum of two smaller sides should be greater than the third largest side. I need not to write other two triangular inequalities, because then it would be obvious, because A is larger than B. So obviously A plus C is going to be greater than B. We need not to write this, right? Now since B plus C is greater than A, let's add A both sides. A plus B plus C is greater than 2A. Why I added a both sides, I think you can guess now, because a plus b plus c is known. What is the value of a plus b plus c? It is 9. So 9 should be greater than 2a, which gives you this condition that if a is the largest side, then a should be less than 9.9 by 2, which is 4.5, right? But at the same time, a should be integer. So if a is integer, we have very limited choices for a. For example, let's take a equals to 4. Remember, a is the largest side, all right? If a is the largest side, then b and c both, they can be equal or smaller than 4. They cannot be greater than 4, right? Now in this case, b plus c should be what? It should be 5. So what choices do we have for b and c? See, b can be equal to, again, 4. The largest possible value of b is 4. b cannot exceed 4. In that case, c will be equal to 1, because 4 plus 1 is 5. Or I have one more choice. b can be equal to 3 and c can be equal to 2. Both are less than 4. So in case you are thinking why we are not switching the values, like b is 2, c is 3, b is 1, c is 4. So see, yes, the values of b and c are different, but the triangle is same, right? We have to count non-congruent triangles. So if I will take b equals to 2 and c equals to 3, it will give you a different pair of values for b and c, but it will give us the same triangle of side lengths 2, 3 and 4. So need not to take 2 and 3 again, 4 and 4 again. I think we have only 2 solutions in this case. In this case, when a equals to 4, we have only 2 possibilities, right? What if we move to case 2? Case 2, where a is, because a is less than 9 by 2, one case was a equals to 4. The other case can be a equals to 3. If a equals to 3, b plus c will be equal to 6. And now, since b and c both must be lesser if compared to a, they can be equal also. I think you can sense that we don't have any other choice except both are 3. Because if you will try to make one less than 3, the other one goes above 3, which is not possible because we have already assumed that a is the largest side. So in this case, we have only one solution, and there doesn't exist any other case. Why? Because if I will take a lesser than 3, like a equals to 2. Suppose if I take a equals to 2, then b plus c will be equal to 7. In this case, apparently, b or c, at least one of them has to be greater than a. So not possible. So how many triangles can be formed? Answer is 3 non-congruent triangles can be formed. What is the level of difficulty? It was better than what we have solved earlier, the first 6 questions. This was not very tricky, but it took some time, right? So question number 7 for you. All right, let's move to question number 8, algebra, right? This is algebra. We have 2 equations in A, B, C, and then we have, we cannot find the values of A, B, C all, do we? Can we? If you look at simple algebra, it says that the number of variables should be equal to the number of equations given, right? There could be some special cases where you have lesser number of equations, more variables, and you can still find the values of those variables individually. But in this case, we just have 2 linear equations. And the question is not that you have to find the values of A, B, and C. The question is that you have to find the value of this expression. A square minus B square plus C square minus 1. So let's try to solve this problem. The very first thing you must observe will be the coefficients, right? If you look at them closely in both the equations, here coefficient of A is 1, C is 8. In second equation, coefficient of A is 8 and C is minus 1. If you look at this 7B and 4, and here I have 4B and 7, there's something going on, right? Did you observe it? If you have observed it, I think if you have observed this, the very next step you are going to write is this, right? Let's shift 7b to right hand side. Let's shift 4b to right hand side. And why I did this? Because now if you look at these two equations, compare left hand side to left hand side, right hand side to right hand side, only these coefficients are switched. Again, look at your problem. We have a square, we have b square, we have c square. So definitely the idea comes in our mind, we should square both sides. Why not? So let's square both sides, squaring both sides in first equation, squaring both sides in second equation. What will happen? You see, if I'm adding these two equations, a square plus 64, c square plus 16ac, and plus 64a square plus c square minus 16ac. What happened? Because the coefficients were not same, they got switched. And there was a negative sign as well. So when we opened a plus b whole square, a minus b whole square, this term got cancelled, right? And same is going to happen to right hand side as well, right? It is 49b square plus 16 plus what? 56b. And the other one is 49 plus 16b square minus 56b. So this term also gets cancelled. And now if you add a square to 64a square, it is 65a square. 64 is c square to 60, so to c square is 65c square. On right hand side we have 49b square, 16b square, again 65b square. And 16 and 49 is 65. So you can see we are getting a square. If I cancel 65 from both sides, a square plus c square equals to b square plus 1. And there you go. Since a square plus c square equals to b square plus 1, a square minus b square plus c square minus 1 should be equal to 0. So your answer is 0. Right? So not just the solution, the way we pick things, right? This was tricky. Yes, I agree this was tricky. Maybe it must have taken some time for you to realize that these coefficients are getting switched, that we have to switch the position of b from left to right, and then we have to square, right? So it might have taken 2-3 minutes to solve, but the question was not that tricky that you cannot solve. So difficulty level is, okay, this one comparing to other 7 was harder, a bit hard, right? Let's move to question number 9. One more geometry problem where we have a semicircle with diameter mn. C is the center. Point P, as shown in the diagram, is on Cn, and somehow CAP is equal to CBP, and both are 10 degrees as it is shown in the diagram. So this angle is 10 degrees, and this angle is also 10 degrees. Where do you see such things? I mean, if you look at CAP, angle CAP is 10 degrees, and also angle CBP is 10 degrees. Where did you see such a property? I think you can remember it was there in a cyclic quadrilateral. It was there in the properties of a circle. If I take this CP as a chord, the angle subtended by this chord in this entire circle will be same. It is always same. So obviously CBP is going to be equal to CAP. So what can we say about ACPB? Obviously ACPB is a cyclic quadrilateral. And how much you know about cyclic quadrilaterals? At least that Sum of opposite angles is 180, right? Sum of opposite angles. So if I join A to B, this angle is given. This angle is 40 degrees, right? You know about this, right? If I extend this angle, join AB, I think you know that this angle is going to be equal to this angle. And what is the reason? Because sum of the opposite angles is 180. Sum of these two is also 180. So these two angles are equal. If these two angles are equal, look at the diagram again. I'm sorry. Wait, yeah. So look at this diagram again. And this angle, which angle? Angle ABP should be also 40 degrees, right? Angle ABP must be also 40 degrees. Now CBP is 10. CBP is 10. So what is angle ABC? Angle ABC. Oh. Angle ABC. Look at angle ABC. It should be 40 minus 10. It should be 30 degrees. And once you have found angle ABC, look, you have angle ABC here. This angle is 30 degrees now. So look at triangle. Look at triangle ABC. In triangle ABC, what do you see? In triangle ABC, this side, side CB must be equal to C. Why? Because this is radius, right? This is radius of the circle. That means triangle ABC must be isosceles. CB equals to CA. CB equal to CA, so it must be isosceles. And angle, which angle? Angle CAB. Angle CAB also is 30 degrees. So, angle, this angle ACB. Angle ACB must be equal to 180 minus 30 plus 30. Answer is 120 degrees. So in this question, we have used a very basic property of cyclic quadrilaterals, right? Question was a bit difficult, yes. Considering what you have learned in 10th standard, not considering 11th and 12th geometry, coordinate geometry or trigonometry, which you are going to learn, or the level of Olympiads or the question level in KVPY, this question is far too easy. But considering 10th standard mathematics, this question was better. This question was good, right? So answer is 120 degrees. You got it? Let's try and solve the last problem, in which we have 60 power A equals to 3, 60 power B equals to 5, and then we have to find the value of this. Once again, exponents, and once again, we must be feeling a bit vulnerable because, powers inserts, we're not very used to of it. We do not feel very comfortable. So many students, they ask me while looking at these type of problems, that how can we solve these questions without log? Obviously, if I have put this question in the paper, and I've not taught you log yet, so I don't think that I should give you a solution including logs in it. So we have to solve this problem without log. Let's see what we need to find, what we want to find. We want to find the value of 12 to the power 1 minus A minus B divided by 2 times 1 minus B. What is the information we have? We have 60 power A and we have 60 power B. So the very first and very thing which appalls me is that we have information on base 60 and the question is asked on base 12. So what is the first thing which strikes to my mind? Let's convert this base to 60. How can we do that? So I think very easy. I can write 12 as 60 upon 5. 12 is 60 upon 5, and this will be 1 power is 1 minus a minus b, 2 times 1 minus b. Now in exponents, you must have learned that this power will get distributed. This will become 60 power 1 minus a minus b divided by 2 times 1 minus b, and this whole thing is also divided by 5 power 1 minus a minus b, and the power is 1 minus a minus b divided by 2 power 1 minus b. But now you'll say, fine, you got 60, but it is not 60 power a, it is 60 power something else, something weird. Yes, it is. And then in denominator we have 5. What to do with 5? Then I'll say, look at the question. We have some information about 5 also. Look at this 5. 5 is right here. Right? So now let's move from right hand side to left hand side. Look at this 5. 5 can be written as 60 power b. 60 to the power b. Look at this. 60 to the power 1 minus a minus b, 2 power 1 minus b, and divided by, let's do one thing. Do not distribute the power. I will use this whole bracket, and now I'm going to write 5 as 60 power b. How will this help? You see, this is 60 power 1 and this is 60 power b. 5 is 60 power b. We will come back to this power later, but first we are looking at same basis and the numbers are getting divided. So you must have gone through the law of exponents, where you have heard, where you have seen that if values are getting divided in same basis, the powers will get subtracted. 60 power 1 minus b it will become, and this is now 1 minus a minus b divided by 2 times 1 minus b. I think in no time we are going to cancel 1 minus b. Now 1 minus b gets cancelled, and what do we see now? We have 60 to the power 1 minus a minus b whole divided by 2 left. Is it clear? Till this step things are clear, right? What after this? This can be written as 60 to the power 1 minus a minus b whole power half. What says the laws of exponent? If x to the power a whole power b, obviously it is x power ab, right? So if two values are getting multiplied in powers, I can put one power out of the bracket. Eventually they are going to get multiplied. Why I did this? Because now if you look at this expression, it is 60 to the power 1, and where you see negative power, it must get divided. So it is 60 to the power a into 60 to the power b. I hope everybody is understanding what I'm doing. Laws of exponents, which where we have seen this property that 60 to the power minus a is 1 upon 60 to the power a. And I think we are now very close to our answer, because 60 power a is already known. 60 power a is 3, 60 power b is 5. Just substitute the value of 60 power a and 60 power b, 3 and 5. You will get 60 upon 3 into 5 whole power half, which is 4 power half, and answer is 2. Answer is 2. So that's it, guys. This was your question paper. I don't know how much time I took to explain it to you, but I think 1 hour time was sufficient for this kind of paper. There were few questions in last. I believe there were 2 or 3 problems which were good. Otherwise, the entire paper was very average. Nothing compared to what you have faced on last Sunday, right? Last Sunday paper was very difficult. So you attempted very well. I mean, I had a look at the rank list, and you did awesome job. Keep it up. All right, and I'm going to end this meeting now. If you have any doubts left, you can contact me on WhatsApp. I'll be there. Okay. Ciao. Bye-bye.